Sometimes you have a collection of elements that are not in the order that you need them. Fortunately, Swift gives us an easy and customizable way to turn that chaos into order. In this video, we're going to look at how to use Swift's built-in sorting methods, how we can write that code in the cleanest way possible, and how we can sort objects that aren't necessarily sortable as a whole. If you've taken a computer science class or are learning the fundamentals, you've probably learned about some sorting algorithms. Whether that is insertion sort, or quick sort, or merge sort, or something else. And you've probably looked at how to implement those. That's good stuff to know, but in practice we don't usually want to think at that level because those algorithms can get pretty complicated and we're likely to make mistakes in our implementation. Besides, there's almost always a way to optimize things beyond what we know how to do. So for everyday development, Swift has these two methods called sort and sorted. They provide an abstraction around what sorting method is actually used, so you don't have to care. They just ask you for a closure that they can call on any two elements and have you return a Boolean that lets the function know if those two elements are in an increasing order or not. Basically, they ask you how to sort any two elements, and they can extrapolate from there to the whole collection. Let's dig into what that looks like. But first I want to note what the main difference is between these two functions. Sort sorts your collections in place, which is why it's marked as mutating. And sorted returns a new array with the elements sorted. I almost always use sorted, but there are times when the performance can be improved significantly by using sort instead, so it's good to keep that in the back of your head. For the rest of this video, I'm only going to refer to sorted. Looking at these function signatures might be a little intimidating. I know it was for me when I was first trying to read the documentation. I mean, what is rethrows? It turns out throws and rethrows in this context are things that you can just ignore until you actually need them. So let's pretend that the signature looks like this. This is just a function which you can call on a collection. It has one parameter, which is a closure that takes two elements and returns a Boolean. And the function itself returns an array of elements. The closure is where you tell the sorter how to sort. It might look something like this. First, we have an unsorted array. Then when we go to sort it, we have our first and our second element. And we're going to return true when the first element is smaller than the second element. That means we will end up with an array that looks like this in ascending order, with all the smallest elements first, followed by the larger elements. If we change the code to return true when first is greater than the second element, we'll end up with an array that looks like this, with the larger elements at the beginning. So whatever method they're actually using to sort behind the scenes, it will go through, and anytime it needs to make a decision of should this element go first or that element, it will call our closure, and based on the answer, it will know where to put each of those elements. That's already pretty powerful, but it actually gets even better. We can communicate that same thing in way fewer characters because of some really nice syntactic sugar in Swift. Let's see all the steps we can take to reduce our code. This is what we're starting with, the same thing we were just looking at. First thing we can do is make it a trailing closure and get rid of the argument label. Then we can get rid of the return type definition because the sorted method already has that as a part of its signature, so it can be inferred here. If you try to write a closure that doesn't return a Boolean, the compiler will complain. Then, because this is one line, we can also get rid of the return keyword at the end of the closure. The compiler will assume that you intend to return the result of this line as long as it evaluates to a Boolean, which this does. We also get free parameter names that are based on the argument position in a closure. So we can get rid of our parameter names too. $0 will be the first argument and it counts up from there. Then we can get rid of the parentheses because there are no other arguments except this trailing closure. And at the same time, it's now so short that we can fit it all on one line. That is much shorter than our original code, and I like that it puts the central logic right in front of you. We can see very clearly here that we're sorting in such a way that the smaller elements will come first. But don't feel bad if you get mixed up with these short statements, especially when it hasn't made its way into your muscle memory yet. I think it's good practice to start with the fully expanded version while you're working out the logic, and then go through these steps to condense it down from there. Over time, it will become second nature to you. In this case, we can actually take it even farther. There are a bunch of things that line up here to allow for this. First, operators in Swift are basically just special syntax for functions, and functions themselves are closures. And because the signature for the less than operator matches the signature for the closure that sorted needs, and because the elements in our array are comparable, we can just pass the operator itself as the parameter. Last but not least, if we want to sort in ascending order, which we do in this case, and our elements are comparable, which they are, we don't actually have to provide any argument because that is the default behavior. Another thing that makes sorted so powerful is that you don't have to sort on the whole element. You can sort on one of its properties instead. This is super helpful because it's not uncommon to have an object where the whole object is not comparable, but some of its properties are. For example, think about how you would sort a group of people. Would you sort them by age, or by name, or by height? Whatever you chose, you would almost certainly sort them by some specific attribute, not by them as whole people. It's hard to even imagine what that would mean. Besides, in some contexts, it may make sense to sort them by name, but in others, it may make more sense to sort them by interest or height or hair color. And the same is true in our code. Fortunately, Swift makes this really easy to do. Here we have a person struct, which just has a name and a created date. For the alphabetical constant, we sort on the person's name. And for the oldest first constant, we sort on the created at date. If your object has further nested properties, you could sort on those too. It just comes down to whatever makes the most sense in your use case. And that's the beauty of sorted. You don't have to worry about how to sort the elements, you only have to think about what you want to sort them by. A really nice looking way you can do the same thing is to use an extension that I picked up from Johnson Dell that will let you sort on a key path. I won't go into detail here about what key paths are or how to use them, but check out John's article if you're interested. It'll be in the description. A couple of things to note about this extension. First, this method assumes that you want to sort in ascending order, but you can write it in whatever way makes sense for your use case. You could even further extend it to also take in a closure like the built-in sorted function so that your sort order could be defined at the call site. But I'll leave that as an exercise for you to try out on your own. Second, notice that this extension is on sequence, not array. That is because of another very powerful feature of Swift, the collection protocols. Again, I'm not going to go into a ton of detail, but check out the article linked below. It is the most comprehensive article I've seen, and he does a great job of making it understandable. What it means for us here is that this extension will add the sorted method to any type that conforms to sequence. That means that not only can we call it on an array, we can also call it on a set, or a dictionary, or even a string. See, here we have a set, and we get alphabetical sorting from it the same way we did on an array. Here we have a dictionary of the person to number of drinks they've had, and we can get that sorted by the value. So we get it back in the order from least to greatest. And then here we have a string, which is sorted by a property on character called description, which gives us this kind of nonsensical array of all of the characters sorted in their order. So we have spaces and punctuation, capital letters, and then lowercase letters in alphabetical order. And this is so long it got cut off here, so I truncated it. So there you have it. We have now looked at how to use sort and sorted, even though their signatures might be a little intimidating. We've looked at how to use them with as few characters of code as possible. And we've looked at how to sort objects that may not make sense to sort as a whole, but have properties that you can sort on. I hope that gives you a better picture of how to use these methods, and if you have any questions, tips, or tricks about sorting stuff in Swift, be sure to share those in the comments. Thanks, and I'll see you next time.